Hello guys, and welcome back to another episode of chemistry. And of course, today we're going to be talking about another major air pollutant, which is what the chlorofluorocarbons. Okay, we have seen the oxides of carbon. So the oxides of carbon, CO2. We saw the oxides of nitrogen, NO2. Okay, and of course also what SO2. All right, all these are what pollutants. Okay, today we are going to look at the CFCs, okay, called the chlorofluorocarbons. Fluorocarbons. Okay, this is another major air pollutant. All right, in this episode also, we'll be able to explain the concept of the depletion of the ozone layer. All right, we might have heard about this very well, but we probably might not have understood it. Okay, but it's a very, very, very important topic when it comes to what climate change. Okay, so people, in fact, governments, the world is now beginning to take serious attention towards the depletion of the ozone layer. I'm going to tell you how it affects you in case you think it does not concern you. It concerns every one of us. All right, and of course, we are going to deal with it in this episode. Please do not forget to like this video. Liking this video will make other students easily find this video and learn from it as you are learning now. So as you are watching this video now, please, I'm begging you with God, just click on that like button that looks like this. Just click on it now. All right, click on that subscribe button too now, please, now. If you want to see showing red below this video, that subscribe button, if you see showing red, that means you have not subscribed to this particular channel. All right, so please click on that red subscribe button, and of course keep sharing our videos. All right, and I pray for you that this will be your only JAMB in the name of Jesus. Type amen in the comment section if you believe with me. All right, so please, so we're going to look at chlorofluorocarbons. Okay, so before we continue, as usual, I'm going to take a question from the O3 Schools JAMB app. Let's say a question from which year? This is a 2023 question, number 15. 2023 number 15. It's currently being displayed on your screen right now. It says, which atmospheric layer contains the highest concentration of ozone? Which atmospheric layer contains the highest concentration of ozone? A says troposphere, B says stratosphere, C says mesosphere, and D says thermosphere. Okay, so these and many more questions are on this episode. We are going to look at them at the end of the class, so that if you want to run away, that is your business. All right, so please download the O3 School JAMB app. It is all you need to succeed in your exam. That's all the past questions you could ever want to ask for all subjects. Also, it has classroom feature that has lecture notes that are structured according to the JAMB syllabus. All right. If you want to succeed in your exam, you must study with your syllabus, and the O3 Schools app helps you with that. So you don't need to go and buy textbooks outside. You don't need to go and buy past questions outside. In one application, you have everything that you need to succeed. Then we have question search feature, where you can search for question according to to topics, and the question that JAMB has set under that topic will come out for you to answer. What is more is that there's a UTME mock challenge that will conduct for students every Saturday. You compete with your mates, you win prizes, all right, and of course you get used to JAMB pass and likely exam question, and you see yourself building confidence towards the main exam. If your hands are not too busy, go to Play Store, download the application, activate it for a little fee, and start enjoying yourself today. All right, so now let's go to chlorofluorocarbons. Okay, now it is very important to note that the Earth's surface is constantly being bombarded with what we call ultraviolet radiation. Radiation. Okay, that the Earth's surface is constantly being bombarded with ultraviolet radiation. Okay, now this ultraviolet radiation, okay, can damage DNA. It can damage your DNA. It can damage your DNA. All right, so now this ultraviolet radiation is harmful to humans. It's very, very harmful to what? To humans. Okay, and of course, it is even linked to cause what we call skin cancer. It is linked to what? To skin cancer. Okay, in the atmosphere, there's a region that we call the ozone layer. The ozone layer. There's a region that we call the ozone layer. This ozone layer is located in the stratosphere. Okay, if you have the Earth, if this is the Earth, for example, all right, then you have what? The troposphere. Okay, you have the stratosphere, then you have the mesosphere, then you have the thermosphere, then you now have the exosphere. Okay, so in case you do not know, if this is your Earth, all right, this is the Earth. Okay, sorry, EARTH. If this is the Earth, here is called the troposphere. This next layer is called the troposphere. Okay, and then of course this one is the Earth, this one is the troposphere, then this one here is the mesosphere. Okay, mesosphere. Then of course this next one here is the thermosphere. All right, thermosphere. Okay, and this one here is the exosphere. Okay, so please, sorry, it's like I overdrew. Okay, so this is the Earth, this is the what? The troposphere. This is the what? The stratosphere. Stratosphere. Okay, I didn't write stratosphere out. Okay, so this is the stratosphere. Sorry. So this is the Earth. This is the troposphere. This next one is the stratosphere. That is this one I wrote mesosphere here. Is the stratosphere. This one here is the what? The stratosphere. Stratosphere. Then the next one is now the mesosphere. That is this one here now. Is the mesosphere. Okay, this one is the mesosphere. Sorry, the handwriting may be very small, but please understand what I'm doing here. I'm not trying to make you get an overview. Then this one here is the thermosphere. Thermosphere. Then this last one here is the exosphere. Okay, so this ozone layer is located in the what? In this what? In this stratosphere. Stratosphere. Okay, this stratosphere is about 20 to 40 kilometers away from the Earth. This is the Earth. If this is the Earth, this is the what? This is the Earth, this is the troposphere, and this is the stratosphere. So it's located about what? 20 to 40 kilometers above the what? The Earth's surface. And that is where the ozone layer is located, in the stratosphere. The ozone layer is located in the stratosphere. Okay, please take note of that. Now, this ozone layer contains a chemical that we call what? The ozone. O-Z-O-N-E. Okay, it contains the chemical that we call what? Ozone. All right, the chemical that we call what? Ozone. Ozone is an allotrope of what? Of oxygen. Ozone is an allotrope of oxygen. So please take note of that. All right, so what have we seen so far? We talk about what? The Earth. Okay, the Earth being constantly bombarded with ultraviolet radiation, we can what? Damage what? DNA. Okay, and then we went further to say that this what? Ultraviolet radiation can what? Can cause what? Harmful what? Effect to what? To humans. It is harmful what? To humans. Okay, and we say there's a region in the atmosphere. Okay, there's a region in the atmosphere that has what we call what? This ozone layer, and that region is what? Is the stratosphere. Okay, the stratosphere is where the ozone layer is what? Is found. Likewise, we have also what? Said, which is very, very important to note, that this what? Ozone layer contains the chemical called ozone. It contains the chemical called ozone. This ozone layer, what it does is what? Is to absorb what? Ultraviolet radiation. It absorbs A-B-S-O-R-B-S. It absorbs what? Ultraviolet radiation. Okay, before it reaches the Earth's surface. So before it gets here, okay, this is the ozone layer is in this stratosphere. Okay, it's in this stratosphere. All right. So as the sun is what is hitting what? So that's this sun that we see that is hitting us. It's not the real sun. If the real sun hits you, you will roast. Okay. So what happens is that this what? Ozone layer is what absorbs what? That ultraviolet radiation, so that what? Before it reaches the Earth, it has what? Cooled down to what? To a level that what? we humans can bear, and that may be useful to us, because we need sunlight too, yeah? So we do. So now, that is that for that. So the function of the ozone layer there is to what? Is to prevent what? Ultraviolet radiation from what? From hitting us directly. The ozone layer will absorb the ultraviolet radiation before it gets to what? To this what? Earth surface. Okay? So the ozone layer helps living organisms to what? To protect living organisms from what? From exposure or overexposure to ultraviolet what? Radiation. So now, in the stratosphere, okay, that is what? This stratosphere here now, okay? So what happens is that what? The UV radiation, okay? The ultraviolet radiation breaks the double bond. Let me make it clear. In the what? Stratosphere, the ultraviolet radiation breaks the double bond present in oxygen molecule. All right, it is oxygen molecule O2. All right, what happens is that what? It's a double bond. Okay, it has double bond, right? So now what happens is that what? If you have oxygen molecule like this, the ultraviolet radiation, that is UV radiation now, it breaks this double bond to give us what? 2 oxygen what? Radicals plus what? Oxygen. So it gives us what? 2 oxygen radicals. Don't say one big oxygen radical and one small oxygen radical. I know some of you. So it breaks it into what? 2 oxygen what? Radicals. Okay, so in the stratosphere, this is where it happens. So as the UV radiation, the sunlight is hitting the stratosphere, okay, the radiation from that sunlight, okay, will break the double bond in what? In an oxygen molecule to what? To 2 oxygen what? Radical. Then one of the what? Radical, then an oxygen radical will now what? Combine with what? With oxygen molecule to give us the ozone. Okay, so that will now have what? The radical, then plus what? Oxygen to give us what now? O3. Okay, so this is how what? The ozone is formed. Okay, if this was the only reaction that occurs, okay, if this was the only reaction that occurs, then what? The ozone layer the ozone in the ozone layer will increase rapidly. Okay, it will increase rapidly and will not have problem. Okay, but of course this is not what happens. Then likewise this what? Ozone, this O3, this ozone O3 can also absorb UV light again. It can absorb O3 can absorb UV light again to break down to what? To oxygen radical and what? An oxygen molecule. So it can happen again that what? This O3, okay, will absorb UV light. To absorb UV light and break down to what? Oxygen radical and what? Oxygen what? Molecule. So this is what the ozone layer actually does. So as the UV radiation is hitting the stratosphere, okay, the ozone layer in the stratosphere, what happens is that what? It absorbs that what? Ultraviolet radiation and breaks down what? The chemical ozone into what? Oxygen radical and what? An oxygen molecule. So now the ozone layer is what? Is normal. Okay, so if you notice, the ozone is formed, okay, from what? Oxygen radical and oxygen molecule to give you all this ozone, okay, and it also breaks down again in the presence of what? Ultraviolet radiation to give what? Oxygen radical and what? An oxygen molecule. Okay, so that means that what? Because what? This ozone is what? Is formed and is broken down at the same time, then what? The quantity of ozone in the ozone layer should remain what? Constant. Okay, but this is not how it is, because some chemicals, okay, when released to the atmosphere, all right, will cause what? The ozone what? To break down what? Rapidly. Okay, so those chemicals are called what? Chlorofluorocarbons. That one we are looking at today. Chlorofluorocarbons. All right, so now these chemicals, okay, that we call what? CFCs for short. CFC, okay, chlorofluorocarbons, CFC for short. They are what? They are haloalkanes. When we get to organic chemistry, we enjoy ourselves. They are what? Haloalkanes. They are what? Haloalkanes. HALOALKANES. Okay, they are all haloalkanes and they are what? Very, very stable. They are very stable and relatively non-toxic. Okay, they are what? Very stable. They are stable and what? Relatively what? Non-toxic. They are stable and relatively non-toxic. Chlorofluorocarbons are stable and relatively what? Non-toxic. Okay, so now in the past, okay, chlorofluorocarbons were used in many applications, like in fridges and freezers. They were used in what? In fridges and what? And freezers. Okay, they also use what? As propellants in aerosols. Okay, an example is Freon. Example of what? Or chlorofluorocarbon is what? Is freon. F-R-O-E-O-N. Okay, so in the past they had what many what application until scientists now discovered that these chlorofluorocarbons that are being released and produced and released to the atmosphere can cause destruction of the ozone layer. Okay, so until scientists now discovered, that is when what this they're now making efforts to look for what alternative methods, okay, to produce what they can be what used for. Okay, so that is that. But now, what really happens? What really happens? So now, chlorofluorocarbons, when they make their way to the stratosphere, UV radiation, the ultraviolet radiation, breaks the carbon to chlorine bond in the chlorofluorocarbon. Okay, it breaks the carbon to fluorine bond, in the carbon to what? To chlorine bond in the what? In the chlorofluorocarbon. Okay, and then it releases what? A chlorine radical. The chlorine radical that it releases is very, very reactive. Is very, very reactive. Let us see an example. For example, if you have trichlorofluoromethane, for example, if you have trichlorofluoromethane, that is, you have CFCl3, okay? Then, in the presence of what? Ultraviolet radiation, this is what is trichlorofluoromethane. Okay, so now this is what this is a chlorofluorocarbon. Okay, so now if the ultraviolet radiation breaks down what the chlorine to what? To carbon bond. Okay, in this chlorofluorocarbon, what it to give us is CFCl2 then plus what? Chlorine radical. This chlorine radical here that it releases is very reactive. We say it's very reactive. Okay, so in case you didn't get that, all right, so if a chlorofluorocarbon makes its way to the stratosphere, okay, where the ozone layer is present, okay, the UV radiation will break the carbon to chlorine bond in the chlorofluorocarbon, okay, and then of course, this is what will be released, a chlorine radical. This chlorine radical that we're talking about, we say is very, very what? Reactive, is very, very reactive, okay. Now, we say what? Scientists call this process homolytic fission. Homolytic fission. And of course, the carbon, the chlorine rather, that is what? That is released, like we said, it's very, very reactive. It's very, very reactive. Okay, so now, what happens? This chlorine, okay, as it has gotten here now, as UV radiation has already broken the chlorofluorocarbon, and then what? Release what? Chlorine radical. What happens is that it will now combine with the ozone in the ozone layer. Okay, so let us see that reaction. So it combines with the ozone in the ozone layer. So you have what? Your chlorine radical, then plus what? Your ozone. It will react with ozone, and then you now have what? Chloromonoxide radical, then plus what? Plus O2. Okay, you have plus O2. So this is what will happen. Okay, so now the chlorine will what? The chlorine radical will what? React with what? With the ozone in the stratosphere. They will now give us a chlorine monoxide and what? An oxygen. This chlorine monoxide will now react again. Chlorine monoxide radical, okay, will now further react with what? With an oxygen radical. In the stratosphere, there is usually what? Abundance of what? Of oxygen radicals. Okay, there is usually abundance of what? Oxygen radicals from the what? Breakdown of what? Of ozone and what? And the formation of ozone. Okay, so there is usually what? Free oxygen radicals in the stratosphere. So now this monoxide that is formed from this first stage will now react with what? With a chlorine radical to now give us again what we call what? Chlorine radical plus what? O2. All right, so this is what it will give us back. So we have seen the equation. Okay, so let me go over that equation again. In the first stage, the what? The chlorofluorocarbon or the chemical makes its way to what? To the stratosphere, to the ozone layer. Okay, there ultraviolet radiation will break the chlorine to carbon bond, and then it will give us what? This. Okay, to break the carbon bond and release. This is our major concern here. It releases what? This chlorine radical that is very, very reactive. Okay, now that chlorine radical will now combine with the ozone in this stratosphere, all right, to give us what? Chlorine monoxide and oxygen molecule. Then this chlorine monoxide again will now react with a free oxygen radical present in the stratosphere naturally. Okay, then will now give us what? This chlorine radical plus what? Plus O2. All right. So you see what this process is what leads this back and forth, the continuous what you can see what that what this chlorine again can also what react. Okay, this even this chlorine monoxide can react with what with O3, the ozone, to give us what this chlorine radical again. Okay, so this back and forth is what leads to what to the depletion of the ozone layer. Okay, so the more we release chemicals, just what more release what chemicals that have what that chlorofluorocarbons into the what atmosphere. All right, the more the what they react with the ozone in the ozone layer, and the more the what they cause the depletion of the ozone layer. So soon after we don't finish with releasing chlorofluorocarbons, some will come dey hit us, yeah. Some will hit you, your hand will peel. Okay, so it is very, very harmful to humans. It is very, very harmful to humans. Okay, so our actions have to be checkmated. Okay, so actions that lead to global warming have to be checkmate. Okay, actions that acid rain have to be checkmate. Okay, and of course, depletion of the ozone layer is very, very important discussion right now. And so every one of us have to play a role in what in mitigating what this effect. Okay, so this because of this cycle, one chlorine radical can lead to what destruction of many thousand ozone molecules. Okay, so please, because of that, we have to what make sure we play our part in what in making the earth safe for us to stay. Okay, so now we're going to go to the O3 Schools JAMB app and answer some questions. All right, let us see a question from the O3 School JAMB app. The 2023 question, number 15, which we were looking at before. The answer there will be what? Stratosphere. We say what? Which atmospheric layer contains the highest concentration of ozone? So we have the earth, we have the troposphere, we have the stratosphere. So it is located in the stratosphere. Okay, so now let us see 2023 number 35. They say chlorine gas is commonly used in the production of which of the following industrial compounds? Okay, A, ethanol, B, ammonia, C, methane, D, chlorofluorocarbons. So D is very correct. Chlorofluorocarbon is very, very important material in the production of what? Chlorofluorocarbons. So let us see 2019-37. They say which of the following pollutants will lead to the depletion of the ozone layer? Which of the following pollutants will lead to the depletion of the ozone layer? A, they say chlorofluorocarbon. B, they say carbon monoxide, sorry. Then C, they say hydrogen sulfide. D, sulfur 4 oxide. And the correct answer there will be chlorofluorocarbon. There are many thousand questions on what this application. Go to Play Store, immediately download and start studying. And we wish you all the best, and we pray that this JAMB is your last JAMB. Study and succeed. Like, comment, subscribe, keep sharing.